Okay, this video there will be two questions on HCF and LCM exam type questions. So just to go through how we're going to do this. So let's read the question. Mr. Lee has two daughters, Elizabeth and Victoria. The highest common factor and lowest common multiple of their ages are 3 and 168 respectively. If Elizabeth is 3 years older than her sister, find both their ages. Now, of course, in your heart, you might think it's easier to ask Mr. Lee, right? But okay, no, Mr. Lee is not available for you to ask, so we have to try to find using a systematic way. But unfortunately, there's no direct systematic working for you to do. So it involves a bit of analyzing, or a bit of I would say guess and check a bit, but not exactly that. There's still a systematic way to do it. So first thing, what you should do, break down the HCF and break down the LCM first. So HCF is quite obvious because it's just 3, so there's no need to break down, it's just 3 because that's a prime number itself. And the LCM, if you try to break it up, let me just try to do this. If you try to break it up, you would get 2 cubed times 3 times 7. Oh, you should try it yourself first. 2 cubed times 3 times 7. 2 cubed times 3 times 7. Yes. Alright, so we have our HCF and our LCM that is broken up into their prime factors. Alright. Then now comes the part where we have to analyze. I'm just gonna put E for Elizabeth, and then I'm gonna put V for Victoria. Now my recommendation is you'll see me trying to fill in numbers later. My recommendation is when you are doing this in exam, for this portion, use pencil first so you can erase. Or unless you are those that don't mind cancelling. Now, both of them has a highest common factor 3. That means both of them will have a 3 at least. Okay. Now, Elizabeth is 3 years older. That means they are about the same. Their age should not have a very big difference. Now, I still have 2 cubed, and I still have 7, which I can give to either one of them because that is the LCM. The highest possible number, no, the both of them cannot have 2. For both of them, one of them must have 2 to the power of 3. The other one cannot have 2 because if you see, I just let you try. Right? If Elizabeth have 2 cubed and V has any 2, what's going to happen? The common factor, highest common factor will not be 3 anymore. There will be a 2 inside. Yeah, so one of the party cannot have 2 if the other one already have 2. And thus in this case, 2 cubed must belong to one and 7 belong to the other. And in this case, Elizabeth is the elder sister. 2 to the power 2 cubed is 8, right? Yes, so it's a bigger number. I'm going to give that to Elizabeth, and I'm going to give the smaller number, which is 7, to Victoria. So let's calculate what is their age if we do it this way. 8 times 3 will give you 24. And 7 times 3 will give you 21. Does it satisfy? Yes, Elizabeth is 3 years older than sister. Then we double check again, do a logic check whether you satisfy the question. If we base on this, the HCF is 3, agree. LCM is 2 cubed, yes, because V don't have 2 cubed. And then common factor 3, yes. And then 7, only Victoria has 7, E don't have, so it's 7. So that's it. Satisfy both. The answer is just 24 and 21. Now, it's a bit hard to do very systematic working here. So sometimes, even if you don't do working, the examiner might mark you correct. But I don't advise that. At least write something like what I did. Or write out the HCF, LCM. It will help you a lot in comparing your answers. Okay, let's do the next question. Very short question, but I think to some students, this is even harder than the sister's question. Okay, let's read it together. The HCF of two numbers is 15. Given that the sum of the two numbers is 120, find the two numbers. Now, in HCF and LCM multiples, we are used to multiplying and dividing. So when they throw in this relationship, which is which is a sum, you realize that all the factors that you try to all the not factor, all the technique that you used to use doesn't seem to work anymore. But it's okay. Come, let's try HCF. Let's break up the HCF first. So HCF 15 is quite simple. I'm not going to press calculator. It's just 3 times 5 because these are the prime numbers. Now let me call one of the number x and the other number as y. Now since the HCF is 15, both of them must have 3 and 5. At least. And the sum is 1, 2, 0. Now I want you to think of it this way. These two numbers, we add them together is 1, 2, 0. And this is just the minimum. 3 and 5 is the minimum. So minimum, they will have at least have 15, right? If we add these two numbers together, that will be 30. 1, 2, 0 minus 30 will give you 90. Now, whatever we add here is not an add. I mean, that's just a way. We any factors that we throw in here will always be a multiply relationship. So it will be a multiple of 15. X will be a multiple of 15. Y will also be a multiple of 15. And let's look at this. What is left? 90. 90 divided by 15. What do we get? I'll press the calculator. You get 6. So I have about 615, which I can allocate between X and Y to satisfy the sum of the two numbers to be 1, 2, 0. Of course, if I want to allocate 1 to X, 1 of the 15 to X, I cannot times 1. Times 1 is as good as not allocating anything. I have to times 2. Times 2 means I have 15 times 2, 30. That means I'm allocating an extra 15 to it. That's what it means. So we can play around. I can, if I times 2, okay, I'm just going to use a different color in let me see, right click. Yes, to show that this is a try. Okay, I'm going to try first. This one is like pencil. Now, if I add a 2 to here, that means I'm allocating 115 to X. That means I still have to allocate 5 more because total is 6, right? I have to allocate 5 more to Y. That means my Y I must times 6. 3 times 5 times 6. It will satisfy the 1, 2, 0 because 3 times 5 times 2 is 15 times 2, 30. 3 times 5 is 15. 15 times 6 will give you 90. 90 plus 30 is 1, 2, 0. But it cannot be the case. Why? Because number one, 6, if you break it down, is 2 times 3. And it has a 2 inside. So if this is 2 times 3, your HCF will no longer become 3 times 5. It will become 2 times 3 times 5. So if you have X as 2, have a 2 in X, Y cannot have a factor 2. So it cannot be this case. So I'm going to erase. Just now we try to allocate 1. What if we try to allocate 215 to it? If we want to allocate 215, we must times 3. Yes? 15 times 3. So in reality, we are adding 30 to it, right? To your original 15. That's why we have 45. Now this one, I would have how much left? I would have 4 times 15 left. So I have 2 times 5. So again, logic check. 3 times 3, 9. 9 times 5, 45. This will give me 75. And you'll get 1, 2, 0. Now, does this satisfy the HCF? Because it already satisfied the sum. Okay, let's see. Let me erase this part first, the logic check. And then I want to adjust this also. This, if it's a 5, nobody will write this way. We will write usually as like this. 3 times 5 square. And then this will not write this way also. We write this way. So let's double check. 3 square times 5 and 3 times 5 square. What will be the common factor? Highest common factor. Remember, we take the lowest power. Yes, 3. Yes, 5. Oh, yes, so it's correct. So the two numbers are 45 and 75. Once again, HCF and LCM numbers don't really have a lot of systematic working about it, but try to at least write something for yourself and for the marker to see actually.